Artificial intelligence has become very popular in the last 10 years. With the development of AI, problems such as image and voice recognition could be solved. Hello everyone from Trans Academy. In this video, we'll introduce deep learning with TensorFlow. Before moving on to the lesson, we produce content related to data science, artificial intelligence, machine learning, deep learning, and programming. Don't forget to subscribe to our channel and turn on notifications. Although the idea of AI back to the 1950s, have you ever thought about why this has improved in recent years? First of all, the amount of data produced has increased with the development of the internet and technology in recent years. With the increase in data, AI models could be trained. Another reason is the growth of the gaming industry and the development of graphic cards. A lot of calculations are made while training the AI model. With the development of GPUs, calculations that could take years could be made within days. In recent years, another reason for the development of AI is the development of state-of-art algorithms. We will take a closer look at these algorithms throughout our lessons. AI is a broad field. Machine learning is a subfield of AI. With machine learning techniques, patterns in the data are found. In other words, information is extracted from the data. Machine learning algorithms were insufficient to find patterns in big data. Deep learning techniques were used to analyze big data. Deep learning is a subfield of machine learning. Deep learning techniques are based on artificial neural networks. Artificial neural network consists of an input layer, a hidden layer, and output layer. While deep learning network consists of multiple hidden layers. In this video, I am going to talk about what are deep learning networks and how do they work, how to set up TensorFlow, and how to do deep learning analysis with TensorFlow. Let's get started. Deep neural networks have been developed by imitating the human brain. The first layer is the input layer, as I just mentioned, and is passed through this layer. The data is then weighted and a bias is added. Initially, the weights are randomly chosen and the bias is taken as 0. There are units in the hidden layer. You can determine the number of these units according to your analysis. Incoming data by weighting passed through the activation function in these neurons. It has various activation functions such as ReLU. For example, the ReLU function takes value less than 0 to 0 and values greater than 0 to itself. Nonlinear patterns in the data are learned with the activation functions. Data goes through hidden layers and the last output comes to the layer. If your problem is a classification problem, there are as many neurons in the output layer as the number of categories in the result variable. As you know, a numerical value is estimated in the regression problem. If your problem is regression, then there is a neuron in the last layer. The last neural networks predict a result with its output layer. But how accurate is this result? The loss function is used to evaluate the accuracy of the model. The loss function compares the actual value with the predicted value and it calculates an error. We want this error to minimum. Science spaces are chosen randomly. The first estimate of the model is bad, so the error will be large. So far, the data has passed through the neural network forward and a result has been created. The next step is to update the weights to reduce the error. Using the gradient descent technique with optimizer such as Adam, the errors are distributed backward and the weights are updated. With the updated weights, the data passes through the neural network again and the model produces a new result. Again, the loss function calculates the error. The calculated errors are distributed backward and weights are updated again. Thus, this process continues until the error of the model is minimum. TensorFlow is an open source machine learning platform developed by Google. With TensorFlow, you can easily make your deep learning analysis. It can be used in PyTorch, developed by Facebook for deep learning. But TensorFlow is more preferred for end-to-end projects. To install TensorFlow, you first need to install Python. You can download Python from its official website and install it on your computer. I recommend using a virtual environment to work with TensorFlow. The virtual environment is used to prevent the libraries in different projects from colliding. You can set up a virtual environment with the pip used to manage package in Python. You can find out how to set up a virtual environment with pip in Python's official documentation. But my advice to you is to use the Anaconda platform for a virtual environment. Anaconda is a platform that includes the necessary libraries and tools for data science projects. Many important libraries come loaded with Anaconda. If you want, you can set up a virtual environment in Anaconda. Let's open the Anaconda prompt. The basic environment comes across at the opening. Don't forget that libraries that are loaded when you install the Anaconda are in the base environment. We will create a different environment in Anaconda by setting up the virtual environment. Conda is used to manage packages and libraries in Anaconda. Let's create a virtual environment called TensorFlow with Conda. Conda create --name TensorFlow Python equals 3.8. I specified the Python version to be installed in the virtual environment with the Python equals 3.8. When you go to TensorFlow own website, it says that TensorFlow has been tested and supported with the Python 3.6, 3.8 versions. If I had not specified the Python version, the final version of Python would have been installed. The latest version of Python can also be used, but you may encounter some bugs as TensorFlow has not been tested with the final version. When you press the enter, the virtual environment is set up, and I will not install it again because I installed it before. Okay, we set up a virtual environment in Anaconda. Now it's time to install TensorFlow in this environment. Make sure that the virtual environment is activated while installing TensorFlow. Let's activate the virtual environment. Conda activate TensorFlow. You can understand that the virtual environment is activated from the TensorFlow text at the beginning of the line. Setting up TensorFlow is easy. Let's set up TensorFlow. Pip install TensorFlow. TensorFlow is loaded with this command. Normally, Conda command is used to load package into Anaconda. TensorFlow's official website suggests using pip to install TensorFlow. With Conda, the final version of TensorFlow may not be installed, but with pip the latest version of TensorFlow will be installed. When we press enter, TensorFlow is installed. I will not install it again because I installed it before. Later, friends who will watch these TensorFlow lessons can use the latest version of TensorFlow. Since I will use the basic commands in these lessons, there will not be much change between versions. Jupyter Notebook is often used in data science projects because it visualizes data well. Let's install this notebook in our virtual environment. Let's start install Jupyter Notebook in Anaconda to Google. Let's go to Jupyter Notebook site. I copy the command here and pass it into the command line. When we run this line, the Jupyter Notebook will be loaded. Let's open this notebook now. Jupyter Notebook. After Jupyter Notebook is opened, let's go desktop and create a new Python file. Let's import TensorFlow with TF. Import TensorFlow as TF. If you don't get any errors, when you run this command, it means TensorFlow has been installed without any errors. You can also use Colab to work with TensorFlow. Colab is a cloud service similar to Jupyter Notebook offered by Google. Libraries such as TensorFlow, Pandas, NumPy are installed in Colab. You can use these libraries by importing them directly. To use Colab, you must have a Gmail account. Let's go to colab.research.google.com. I am going to press the New Notebook button to open the new notebook. First of all, let's name this notebook. Don't forget to click on Connect in the upper right corner while working in Colab. Let's import TensorFlow with TF. Import TensorFlow as TF. Let's see the installed version of TensorFlow. tf.__version__. And you can see the version of TensorFlow. You can now build a deep neural network with TensorFlow. Nonlinear problems could not be solved with classical neural networks. Hidden layers have been added to classical artificial neural networks to solve nonlinear problems. Artificial neural networks with more than one hidden layer are called deep learning networks. Extracting information from data using the deep learning network techniques is called deep learning. The following problems could be solved with deep learnings: image classification, voice recognition, machine translation, driverless cars. Let's use the MNIST dataset to show deep learning networks. This dataset contains images of the number 0 to 9 in grayscale in 28 pixels. This dataset includes 60,000 training and 10,000 test images. I will use more complex data in the future. The purpose of using the MNIST dataset in this video is to show how to build a neural network with a clean dataset. I am gonna use TensorFlow and Keras to install this dataset. Keras is a high-level API. Keras joined TensorFlow in 2019. Keras installs automatically when you install TensorFlow. With Keras, you can easily do your deep learning analysis. Let's first import this dataset. MNIST equals TF Keras datasets MNIST. Let's split this dataset into training and testing. The model is established with the training data and the model is evaluated with the test data. Let's write xtrain, ytrain, xtest, ytest equals MNIST load data. And run this command. The images in the dataset are encoded as a NumPy array. Labels are numbers from 0 to 9. Let's look at the shape of the datasets. I'm gonna set print xtrain.shape. Let's copy this command and edit it for test data. I'm gonna set test. Let's run this. Scanning data in deep learning analyzes both speed of the training of the network and increase the accuracy of the network. Let's scale the data between 0 and 1. Xtrain, xtest, xtrain 255, xtest 255. Now, we can start building the neural network. You can create the neural network as a sequence of layers. You can think of layers as a filter that extracts information from data. I will use the sequential techniques for this analysis. Model equals TF Keras models sequential. The first layer is the input layer. Flatten is used to smooth the entries in the input layer. TF Keras layers flatten. Let's enter the size of the input in the input shape argument. Input shape equals 28, 28. The second layer is the dense layer. The dense layer is called the full link. All neurons in this layer are connected to all previous neurons. TF Keras layers dense. Let's set the number of neurons in this layer to be 128. Layers can learn only linear transformation of inputs. Activation functions are used to learn more complex patterns in the data. It has activation functions such as elu, tan, but most ReLU activation function is used in deep learning analysis. The ReLU function takes negative values to 0. Let's write ReLU to the activation function in this layer. Activation equals ReLU. If the model shows good performance in training data, but poor performance in test data, an overfitting problem arises. The regularization technique is used to overcome the overfitting problem. There are regularization techniques such as L1 and L2. Let's use the dropout techniques here. Dropout is a regularization technique used for neural networks. When dropout is applied to a layer, a random part of the output is dropped during training. Thus, excessive memorization of the model is prevented. TF Keras layers dropout. Let's write 0.2 in the dropout method to drop 20% of the output. The last layer is the output layer. I'm gonna set TF Keras layers dense. Let's write 10 to this layer since there are 10 classes in the target variable. Notice that I didn't write an activation function in the last layer. So I built a neural network architecture. It's necessary to compile the model to prepare the neural network for training. To compile the model, you need to specify the optimizer and the loss function. Optimizer updates the weights used in the neural network according to value of the loss function. There are various optimizer functions such as RMS probe, stochastic gradient descent. The ADAM optimizer has become particularly popular in recent years. This algorithm is an extension of stochastic gradient descent. Let's set ADAM as an optimizer. The loss function measures the performance of the neural network over training data. It does this by comparing the estimate of the neural network with the actual value. TF, Keras, loss, sparse categorical cross entropy. You can use sparse categorical cross entropy as a loss function when you have 2 or more classes. In this analysis, I have 10 classes. I'm gonna set sparse categorical cross entropy. If you have coded labels with 1 hot, you can use the categorical cross entropy loss. Since I don't use the activation function in the output layer, I'm gonna set the option from logits equals true to the loss argument. The matrix argument is used to see the performance of the neural network. Since the analysis is a classification problem, let's use the accuracy metric. So far, I have built the architecture of the model and compiled the model using the compile method. Now the model is ready for training. Now let's train the neural network by calling the fit method. I'm gonna set model fit x train y train epochs equals 5. Each iteration on training data is called an epoch. So it takes one epoch for all data to pass through the neural network once. At each iteration, the neural network updates the weight according to the loss function. During the training, the loss and accuracy of the network were written on the screen. After the 5th epoch, the accuracy of the model was about 0.98. After training the model, evaluate method is used to evaluate the performance of the model on the test set. I'm gonna set model evaluate x test y test. Thus the accuracy of the model on the training data was written on the screen. The accuracy of the model on the training data also turned out to be about 98%. The accuracy value of the model on the training data is desired to be close to the accuracy value on the test data. So we built our first neural network. We will mention deep learning networks more closely in future lessons. Thank you for watching the video. Don't forget to subscribe to our channel and turn on notifications. Bye for now. To see you in the next video.